Climate change is the name given to the variations of temperature and changes in weather patterns seen across the globe in the 20th century. Since the Industrial Revolution in the 19th century, the average temperatures of the Earth has risen by 0.89 degrees centigrade from 14 degrees centigrade. Climate change is caused by greenhouse gases such as CO2 getting trapped in the atmosphere, which then prevents the heat from the sun escaping. The gases are mostly a result of increased use of fossil fuels by humans. As the Earth heats up, the temperature of the oceans rise and the volume increases. In addition, the ice caps start to melt. For example, the Arctic sea ice has been shrinking by about 4% or 0.6 million square kilometres every decade. This increase can flood low-lying land. Regions built at sea level, such as the Cook Islands shown here, could be flooded permanently. Since 1900, the oceans have risen 10 centimetres around the UK and 19 centimetres around the world. As well as the Earth heating up, there will be changes in weather patterns across the planet. Some countries may have long droughts, while others could have months of torrential rain. This could cause more food shortages and less clean drinking water available. Geoengineering is the deliberate large-scale intervention in the Earth's natural system to counteract climate change. Geoengineering is split into two sections: solar radiation management and carbon dioxide removal. There are three types of geoengineering which fit into the category of solar radiation management. They are albedo enhancement, space reflectors, and stratospheric aerosols. Albedo enhancement is to artificially increase the reflectiveness of cloud cover or ground surfaces to reflect back some of the sun's rays. It stops the heat from the sun being absorbed and then re-emitted. The radiation from the sun is reflected back into the atmosphere, which stops the Earth warming up as much. It is very efficient, but it is incredibly expensive, and there is a huge amount of uncertainty about what it will do to the planet. Space reflectors are shields which reflect some of the radiation from the sun before it enters our atmosphere. An idea was to create a dust-like ring around the planet, like the rings around Saturn. These particles will reflect the radiation away from Earth. The positives of these reflectors are they'll have a long lifetime and they'll show benefits very quickly once deployed. However, they'll be very expensive to install and maintain. Stratospheric aerosols would artificially spray particles into the air which scatter the sunlight back into space. The particles are scattered into the air by planes or ships. These particles will then scatter the incoming sunlight, sending some of it back into space. The positives of this idea are that it is very cheap and very effective. However, it's uncertain what will happen to the planet if we use this form of geoengineering. There are 7 types of geoengineering which fit into the carbon dioxide removal category. They are afforestation, biochar, ambient air capture, ocean fertilization, ocean alkalinity enhancement, enhanced weathering, and bioenergy with carbon capture and sequestration. Afforestation is the idea to plant lots of trees. The more trees we plant, the more carbon dioxide they need to photosynthesize with. This means they'll produce more oxygen. It is a very cheap and safe form of geoengineering, but it will take a long time for the trees to grow, and there may be less food for the planet if we take up crop space to plant these trees. Biochar is when someone burns organic material and buries it so the carbon in it is trapped and doesn't gradually enter the atmosphere as it decomposes. Biochar is very cheap, but it may not be safe for the environment because in the natural carbon cycle, biomass is always decomposed and emitted carbon. If we stop it, we don't know what the effects will be. Bioenergy with carbon capture and sequestration, or BECCS, is where organic matter is grown and then burnt for fuel and the CO2 is captured and stored at an energy plant. It stops the plant matter decomposing and letting CO2 into the air. This produces energy and is a safe form of geoengineering, and it would affect the amount of CO2 quite quickly. However, BECCS is still producing CO2, which must be stored. Ocean fertilization is when you add nutrients to the ocean to increase the activity of organisms such as algae, which, by photosynthesizing, will remove carbon dioxide. The dead algae will fall to the bottom of the ocean, therefore locking away the carbon. Although it would work, there are many downsides. It is not cheap, there may be unintended consequences, and it would be very, very slow. Enhanced weathering is the use of natural chemical reactions between common minerals such as silicates and CO2 to lock away gases. The rocks would be ground up and spread on fields to absorb the carbon dioxide. It is a very effective method as it is a natural process, but it is unclear what the effects will be on the soil, and huge quantities of these minerals must be mined and ground up. Ocean alkalinity is linked to enhanced weathering. Here the product of the reaction between carbon dioxide and minerals in rocks is put into the oceans to lock it away. These products tend to be alkaline and will increase the alkalinity of the oceans. This is a very effective method of removing CO2 from the atmosphere and also corrects the increase in acidity of the oceans caused by CO2 dissolving in them. However, it is slow and may have some adverse side effects on marine organisms. I have chosen to specifically research ambient air capture. This concept is one of the most feasible ways of scrubbing the skies of CO2. The method is possible because of techniques developed at NASA who have been scrubbing air for years in their space shuttles. CO2 is routinely scrubbed from power station waste gas, but CO2 which is released every day by small sources, such as cars, cannot be easily removed as it is produced. It pollutes the air and is then at a lower concentration and needs special methods to remove it. One such special method is to channel air through a machine which sprays a CO2 absorbing liquid into the air as a mist, or use gravity to let it fall through the air. The CO2 will then react with the liquid to form a carbonate solution. The air can be pulled through the machine by fans, and the air coming out of the other end of the machine would have up to 80% less CO2 in it than the air entering the machine. The carbonate solution would then be taken to a factory and be treated to take the CO2 out of the liquid so it could be used again. The CO2 which is taken out of the carbonate solution could be added to hydrogen and, with some processing, be made into hydrocarbons, which could be used as gas or aviation fuel. The hydrogen needed for this could also be produced without CO2 if the energy needed to split the water molecules came from renewable sources. A prototype machine has been built in Canada by a company called GeoEngineering. They hope to place these machines all over the world, but particularly in places where people cannot live or work, but where there are sources of renewable energy, for example, deserts. Climate change is a huge problem facing the 21st century. As the world is finding it difficult to reduce the CO2, we need to learn how to remove it. Solar radiation management techniques would seem to be too expensive and too dangerous to use. Carbon dioxide removal techniques seem more possible, although they will be slower. I hope that more research will be done on ambient air capture as it seems to have many possibilities.